So let's get going on this. The big picture goal here is we need the coefficients in front of the variables to be the same number but with opposite signs. It's like a 2 and a negative 2, a 3 and a negative 3, a 10 and a negative 10. That's what we're looking to achieve. Now, I'm going to go after the x variables here. They're the easier ones. But if you wanted to cancel out the y's, they're already opposite signs, which is good. You would turn both of these into a 21 via multiplication. But I'm going to go after the x variables. Most of us tend to go after the x variables, try to make them the same number opposite signs. And it's not that hard here because you only have to multiply the bottom equation. If I multiply the bottom equation by 3, this will be the 3x that I need. But 3x and 3x don't add together to cancel, so I need to actually multiply by a negative 3. Doing so, I get negative 3x plus 9y equals 3. A lot of sign changes, be careful. Now I draw a line through that equation because I'm done with it for now. I'm ready to add these equations together. 3x and negative 3x, those cancel out, leaving me with 16y equals 16. Divide by 16, divide by 16. I get that y equals 1. Okay, there's half my answer. Now I got to go find the other half by substituting that in. That's why we learned substitution before elimination. I would really like to use the bottom equation. I think it was easier, but I drew a line through it already, and so that's enough reason for me to just not use it. Because I know I can use any of these equations, and I'll get the right answer. So I'll use the top one, 3x plus 7 times y. Well, y is just 1, equals 13. 7 times 1 is just 7, and I'm going to subtract that from both sides. I get that 3x equals 6, and thus x equals 2 for a final answer of 2, 1. Starting with number 11, okay? This is where we get into the mixed practice. We've already done a lot of mixed practice. We spent an individual day on all of these topics and spent an entire day on mixed practice, and then did a mini review. If you were here on Friday, did a mini review that had mixed practice. This is solve it by any method you want, okay? Any method. You've got graphing, solve it for y. You've got substitution, solve one of the equations for a variable. You got elimination, where you got to line everything up nicely, okay? And that's actually what I think of when I see number 11 as elimination method, okay? Because they are both in standard form, ax plus by equals c. They're already stacked up on top of each other very nicely. So now I choose which variables to go after. 6 and 8. I'd be looking to see what number I could turn both of them into. I could turn them both into a 24. Okay, that'd be multiplying the top equation by 4, bottom equation by 3. Other people like to just flip the numbers. They say, I'll multiply the top by 8, the bottom by 6, and it'll work. Both of those would work. I'm going to go after the y variables here, just because I haven't done that yet. Okay, I kind of want to look and see what that's going to look like, just to show people. Let me get this number out of the way. Okay. So, also, people are good with 5. People are really good with multiplying and manipulating the number 5. So maybe that's what you decide to do here. I want 4 and 5 to be the same number, but opposite signs. They're already opposite signs, so that's easy. That's done for me. But the number that they both share is 20. So the multiple that they both share is 20. So I'm going to multiply the top equation by 5 and the bottom equation by 4. When I do that, I'm going to get a negative 30x minus 20y equals 90. 80. Whoops. Sorry about that. Okay, I knew that something was about to be off. On my bottom equation, I get a 32x plus 20y equals negative 88. And now I'm ready to combine. When I combine, these cancel out just like I wanted them to, and I get 2x equals negative 8, and thus x equals negative 4. That is half of my answer. To get the other half, I'm going to plug that into one of my original equations. I'll plug it into the bottom equation. Okay, you could use either one. Top one just has more negatives, and I don't like negatives that much. So I have 8 times x, but I know what x is now. It's 4. Plus 5y equals negative 22. That means I have 32 plus 5y equals negative 22. Oh, I'm sorry. I see my mistake. Boy, struggle of a problem for Mr. Sorrell. Oh, my Lord. That's a negative. Okay? So whenever I have negative 32, I'm going to add that to both sides. That's going to cancel out. I get 5y equals 10, and thus y equals 2. So I started to pause because I'd just gotten that so wrong that I started to pause and be like, I'm just going to redo this video. I'm going to start over from scratch. And I decided not to, and not just out of just not wanting to do that, not because this video is very long so far, it wouldn't take much time, but because I needed you to see that, and not really needed, like did it on purpose, because that was for sure an accident that I just made all those mistakes. But that was good for you to see if you think about it. Because I was looking here and realizing I wasn't going to get something that divides whenever I had it wrong, whenever this negative wasn't there, okay? Whenever this wasn't there, I was realizing I'm about to subtract 32 from both sides. This is going to be like a negative 54. Like, that doesn't work. I kept thinking, I was like, where did I go wrong that this is not going to divide out evenly? Because, guys, we're going to get nice, pretty answers on this test. I'm just telling you now. I'm not going to give you answers that are like crazy decimals. Like, the worst one we got while doing these in class was like a half as an answer, like 1/2 or 0.5. You're not going to get some weird, really weird answer. So I was looking, I was like, how did I mess this problem up? Because I could tell it wasn't going to work out to be a nice, even finish, okay? If you're working through one of these problems and you get stuck and you're like, man, this is just not working out, I'm getting weird numbers, go back, find your mistake. That's what I did. Go back. I went back. I was like, where's my mistake? Like, what did I do wrong? I just started backtracking. I was like, okay, I plugged in my 4, and I looked right over here. I was like, oh, it's a negative 4, okay? And then I doubted myself again. I was like, no, it's still wrong. And I realized, no, it's okay. It's working out now, all right? Again, you can always go back and check your answers by plugging them in. That's why this is not a multiple choice test. Okay? For number 12, they're all decimals, and I've got to make that go away. To do so, I'm going to just multiply both equations by however many places I need to move it. And I need to move it one place, so that's 10. Multiplying by 10 is our mathematical way of moving a decimal one place to the right. When I do that, I get 2x plus 6y equals 36. Don't forget to move this decimal as well. I get 4x minus 9y equals negative 12. And I want to run elimination on this because they're already set up. They're in nice standard form for me. Okay? I don't want to try to fiddle with making a 6 and a 9 agree into the same multiple, because the top equation can just be multiplied by negative 2, and I'll get negative 4x, which will cancel out. Along with it, I get negative 12y equals negative 72. Done with that one. Add these together. These are going to cancel. Right here, I get a negative 21y equals negative 84. Go grab your calculator, throw this in there, divide by negative 21 on both sides, and we get y equals 4. That is half my answer. When I get that half, I take that and plug it back into one of the equations. Guys, this is one of the rare occurrences where I'm like strategically not going to use one of the original equations. Not that they wouldn't work, but decimal division is not very fun. So I'll just use this one that I created because I can still see it, okay? 4x minus 9y, well, y is just a positive 4. So 4x minus 36 equals negative 12. 4x equals, this would be add 36, 4x equals 24, and thus x equals 6 for a final answer of 6, 4.